Thank you, Heya, for this introduction and also for inviting me to this workshop. Very interesting indeed. And let me the opportunity to present what we are doing in the French ELIXIR node. So I will talk about what we did since 4 years about the cloud for bioinformatics and to analyze life science data. A few words about the Institut Français de Bioinformatics. So we are running since 2 years. We are the national hub of IFB. We are located in Paris. You have there a picture of our building. But IFB is also 36 platforms spread across the country. And these platforms are running for most of them since a lot of years, for some of them 10 years, 15 years, and providing services to the national community and also to the international community. And until recently, most of the services were provided through web portals, scientific gateways, or through a classical cluster with a command line access. So one of our main goal about the infrastructure in ISV is to set up national infrastructure based on cloud to simplify the service providing and the usage by the biologists and by the bioinformatician for the analysis and also by the developers for setting up new tools. So you have there a map of France with the location of the different platforms. You see they are all over the country. We are located in Gif on the southwest of Paris. And we would like to provide support for the national biology programs because at the same time of the Institut Français de Bioinformatics, there were also some national infrastructure that have been set up. For example, one for proteomics called PROFI, one for structural biology called INSTRUCT, one for metabolomics, also for genomics. This one is called French Genomics. So there are a lot of national infrastructure set up during the year 2010 to 2012, and all of them are focusing on some specific aspect of the experimental biology, and EFB is the bioinformatics part, bioinformatics infrastructure, like ELIXIR is the bioinformatics S3 European research infrastructure, providing services to the other one, like LifeWatch or other ones that we saw previously. One of our goals is also to act as a middleman between the computer science domain and the bioinformatics and life science domain. As I said, we are also the ELIXIR French node since September of last year, and then we are the contact point for ELIXIR and making the relay between the national community and the European community. We have, of course, we are also participating to ELIXIR that has been submitted last year and accepted, and the kickoff was in September. We are participating to almost all work packages. Of course, related to this talk, we are participating to the service registry, the P1. We are also participating to the compute platform. But we are also participating to the 4 use cases. We are dealing also with the interoperability backbone and with the ELIXIR node capacity building and communities of practice. That's the ELIXIR Accelerate part of our project. But we have also other collaboration with European projects like Cyclone or EGI Engage, and with national program like Biodata Cloud, which is a French program with some industrial use cases about plant genomics, assembling and visualization. Cyclone is especially important because we are providing the bioinformatics use cases to this project, and they are related to securing biological data or to a cloud virtual pipeline from microbial genomes analysis. And the goals of Cyclone are multi-cloud deployment, federation of identity, network as a services that could be very useful features to deploy bioinformatics infrastructure to help to analyze life science data. So a few words about the infrastructure. itself. So there is a national IT resource that we are operating in ISV core, but there are also 36 platforms. The last one was very recently added. And all these platforms have hardware, data collection, and bioinformatics tools and provide them to the community. And all these resources together represent 15,000 scores and 6 petabytes of storage. But all these resources, all the IT resources, are spread over the different platforms. Some platforms like Institut Pasteur, Institut Curie, Genotool in Toulouse, or Pravi, Nyon, or GenWest in Rennes are larger platforms than the others because they have hundreds or thousands of cores and hundreds of gigabytes of storage, hundreds of terabytes of storage or petabytes. But all the platforms have some resources, and what we'd like is to bring them together in the same infrastructure, almost the most important of them in the first time. We have already 4 running clouds on 4 running platforms, 2 on the ISV premises, 1 in ISV core in ELIXIR-FR, and there, and the other one in the GenWest platform in Rennes, in Brittany. And these clouds are running since 4 or 2 years, since 2011 or 2014, and they are hosted by the own resources of these 2 platforms, the ISV Core and GenWest. And we have also 2 collaborations with some academia resources, one in Lille and one in Strasbourg, where the local bioinformatics platforms are collaborating with the university or with in Lille or with the scientific institute in Strasbourg to put together their resources, their IT resources, and work together to provide a cloud to their own communities. So our goal about these 4 clouds in the first step, and then after that, with the other clouds that will be set up in the other platforms, our goal is to create a federation of clouds for life sciences. And I will provide you some tracks on how we are thinking to do that. So first, some data, some info about the 2 resources in ISV premises. In ISV core, we have yet 200 cores, 50 terabytes of storage, and 2 terabytes of RAM, located in the National CNRS Supercomputing Center called IDRIS, and located in Orsay, in the south suburb of Paris. This pilot is available since 2 years and is running with the Stratus Lab middleware. And one important point is that the largest virtual machine that we can create is with 20 cores and 256 gigabytes of RAM. GenWest is also running its own cloud since 2 years. They have 220 cores, 8 terabytes of storage, and 700 of gigabytes of RAM. And the largest VM that we can run on this cloud is 8 core with 32 gigabytes of RAM. They are running their infrastructure with the OpenNebula framework, and they also have some extensions that are planned because they are planning to add 100 cores and 20 terabytes of RAM. And as us in ISV core, we are planning to add 160 cores and 100 terabytes of storage. That's for the near future. And also, we are planning a larger extension before the end of this year by adding 5,000 soft core and 1 petabyte of storage to this facility. Because right now, we call it a pilot. That's for experimentation. That's for learning how to use the cloud. But some people are also running VM to do real science, to compute their analysis and to make papers with that, but we are still in a pilot phase. There will be the first step of the national infrastructure, that we plan to be available for the second step with 5,000 more cores and 1 petabyte, supplementary petabyte of storage available next year. Another important point is that we are migrating to OpenStack because Stratus Lab is not anymore developed. But this large national infrastructure will be still located in the CNRS Supercomputing Center because there are a lot of advantages of having such infrastructure in terms of stability and reliability and so on. One important point still for this extension is that we are planning to add very large memory servers, making us available to provide users with a larger virtual machine that can be of 64 cores and 2 terabytes of RAM. That can be very useful for some bioinformatics analysis, like genome assembling, or like new images reconstruction, and so on. To set up a multi-cloud infrastructure, the requirements are to have a common identity and authorization management, and this should be based on the standard identity that are available in France, but also in Europe. So in France, the Identity Federation is managed by Renater, which is connected to the EDUGAIN, the European Federation of Identities. There should be also interoperability of virtual images through the virtual machines or through containers. With Docker, it's quite simple. And also, we did some tests between ISV Core and GenWest, and also the cloud in Lille to exchange some virtual machine between Stratus Lab and OpenStack, and it works fine. What we need is also to have tools for multi-cloud deployment, because you would like to provide users with a simple way to launch the same virtual machine, the same Docker container, the same images in general, on several flavors of clouds, and at least to be able, for example, to deploy the same infrastructure on several clouds to recruit more resources to compute a large analysis. So for that, we are planning to use the Slipstream Nuvla broker, and these developments are ongoing in the context of the Cyclone project. You need also to have some network management, security and propagation over several data centers. First, to isolate the virtual machine of a user from the other one, and also to propagate, to make this virtual private network available on the same data center, but across different data centers. And that's also a work that is ongoing in the context of the Cyclone project. What is the context? What is the bioinformatics context in ISV? So as in other institutes, we have many tools. Users are requesting for many tools. You have there some examples of the tools that are available in ISV Cloud through the Docker containers or virtual machine. But we are also some requests. We have a lot of requests also to manage metadata, because they are the collections of reference data that are of size of terabyte. And that way, ISV Core mirrors and computes the indexes, and the platform will be able to subscribe to database update. And then the transfer will be from the ISV Core to the regional platforms. And we are already running at with Bioimage, which is a French development to help you to manage the mirrors of reference datasets. We're also planning to use iROD and GridFTP for that. So the other one is how to manage the experimental data that are produced in the different biological platforms across the country. We plan to have some regional desks in the regional platforms. For initial deposit, biologists can come with a hard disk containing his genomics data or containing some large images, and then put that in the system in the regional platform, and we will manage the transfer with high bandwidth between the regional bioinformatics platforms and the IFV core, if for local archiving or for analysis, if the regional resources are not enough to manage to analyze the data. So we're also planning to do that data management with iRods and GridFTP. These parts, iRods and GridFTP, are still in progress, are not in production yet. And the third use case in terms of data is to manage the user data themselves. There are many, they can be large also, from megabyte to terabyte. They are very heterogeneous, and also they are unpredictable in terms of the distribution, because one user can decide to move it from Lyon to Rennes or to Toulouse or to Lille without having a predictive plan. So for that, we are envisaging to use iRods, object storage, like S3 with the different flavors, or different database system providing NoSQL, like Cassandra or MongoDB or so on. But regarding the data, the two main issues are the transfer, when you are dealing with large data like terabytes of data, and also another issue is the it's a confidentiality and the management of the access to the data in the case, for example, of biomedical data. So how are we creating bioinformatics appliance on the IFV cloud? We do that in a very usual way. We took a Linux system that can be Ubuntu or CentOS, and then on that base image, we added the different bioinformatics tools with the required configuration, with the pipelining that could be scripting, that could be other things like Galaxy. And once the configuration is validated, we save this image, this new image, with the complete pipeline, with the complete bioinformatics application available in a repository, and we register it in a bioinformatics marketplace. So our bioinformatics marketplace is based on the Stratus Lab marketplace, and we provide the users with different interface to browse this marketplace. For that, this is at the level of providing a virtual machine images. These images are created by developers from the French community. They are experts in different life science domains. And that's very important that the images are created by the developers of the different software or of the different pipeline, because they know better than someone else how to configure them. And they are also able to put a new images with the new tools, a new version very quickly. At the level of IAB, what we are trying to do is to help them to be able to publish these virtual images. For that, we are organizing training sessions for developers. We have a cloud support team in IFV Core, and we are also proposing them to come to IFV Core and to have some what we call individual hackathon. That means that you are a developer for tools, of a tool, for pipeline. You can come to IFV Core and spend some days there to integrate your tools, your pipelines, your environment in a virtual machine in our offices, and we can help you if you have some trouble. Yes?
So somebody has a new tool that would like to add into your system. So adding this tool into the system, does that mean they create an image with it, or will this be compatible with all the other tools? Like if you have like a Galaxy suite where you would just like to add a tool,
yeah.
Is that, so do we need to inject it into each image? Or?
No. You can inject this tool, your tool, in all the images if you want, but generally the images are maintained by some responsible, some developers. So the best way is to create a new Docker container or a new package with other things. Like in Galaxy, you can provide with wrappers and put it in the tool shed. That's the way you can provide your tool as a developer. But you can also create a specific image devoted only to the pipeline you created, or with the Galaxy interface, or with the command line, or with a remote desktop, like who is.
Yes. Okay. So yes. Yeah, so pushing your tool is making all this glue, all these wrappers for the different.
If you want, you can provide it as it with the tar.gz, like a standard package, and put it in, or not at all packaging it, putting it directly in a virtual machine image, and providing the scientists, the engineers, with the virtual image to run their own virtual machines. But we are trying to work on the different way of packaging the tools with standard way, tarball, some bash script, some Puppet or Ansible or Chief recipes, or Docker containers. That's the way how you can package your tools, and then after that, how to provide them to the users. They can get this package or get complete virtual images that can be run as a virtual machine. Once you created your image, your virtual machine image, you can register it in our marketplace. So the marketplace is based on the Stratus Lab marketplace technology for the management of the images and the different process to get the images and run it on the Stratus Lab cloud infrastructure. But with the cloud marketplace, with the Stratus Lab marketplace, and also with the help of ELIXIR BioTools services registry, and also with the Docker Hub provided by Bioinformatics, the French Docker Bioinformatics registry. We try to integrate all these metadata for the different appliances, virtual images, tools, in a single interface, where there are scientific apps. You can browse for NGS, bioimaging, proteomic virtual images. You can also browse for utilities like CentOS or Ubuntu data management system or batch scheduler. You can also browse the registry about the interfaces, command line, web portal, remote desktop. So we gather all these metadata to provide one unique interface where the user can browse the different appliances or browse the different tools that are available in these virtual images, or with EDAM topics term, browse the different tools, providing a solution for these topics, or identify, filter the different virtual images to that can provide an environment to help, for example, for structural biology or for protein structure analysis. But we will practice that during the hands-on after that. Another way of providing users with virtual images are with the Docker technology. We saw Docker more as a way of packaging tools, packaging pipelines, but even for the pipelines, the better way is certainly to have different containers for the different tools, and then using Docker Compose to assign them in one registry. But what we are doing is that we are providing a virtual machine with the Docker layer, and as in the IFB cloud, each user has its own virtual machines that are not shared with other users. Then we can provide the users in that virtual machine with the root access, and there are no more security problems with that, because users are running their virtual machine, and on top of that, they are putting the Docker containers. So in the cloud, as a developer, you can set up your tool as a containers. You can then push this Docker file to the French Bioinformatics Docker Hub called Bioinformatics, and hosted at the GenWest platform in Rennes. You can also get other containers to integrate them in your pipeline. And once the container is registered in the Bioinformatics Hub, standard users can use them in their own virtual machine. But also you as a developer of a virtual machine, you can get these containers and save them in the virtual machine image and then provide the scientist with a virtual machine including the images of the Docker containers that you have arranged for your pipeline in a command line way or behind Galaxy. For example, we are providing an image with Galaxy running different tools that are themselves stored in Docker containers. And that's very easy to add new tools if they are registered in the Docker Hub. You can also, of course, use the main Docker Hub or other Docker Hub from other places. Our goal by working with cloud, working with providing some virtual images, are to move the virtual images rather than data, because data could be of terabyte and or more. And the virtual images most of the time are on the size of gigabytes, so it's more easy to move these virtual images where the data are and where you can analyze your data without moving them. That's when the data are big data, but also in the case of the data are sensitive data, like in hospital or like in industry. The data cannot go out of the local resources, and then a very easy way to bring the way of analysis these data are to provide the users locally with the virtual images that can be downloaded from the IFB marketplace. How you use the IFB Bioinformatics cloud? So as a user, you have some cloud credentials. You have an account on the IFB cloud dashboard. And with that account, you log in the web interface. And then there you are able to manage your virtual machine, manage your virtual disks, and you are able to run your own virtual machine. The virtual disks are personal, and all users are their own virtual disk, and they are not shared with the other users. All virtual machines also are personals, and people are running their own virtual machines. We are providing all the running virtual machine with the reference dataset, like the genomes, like UniProt, like ProSci, that we are updating with the bioinformatics system from the reference public data sources. And these reference data are shared through NFS in a read-only mode to all the virtual virtual machines, that are needing them in for the analysis. For example, we are providing with the common reference data, but as a developer of an appliance, you can very easily set up your own reference data in the IFB cloud and provide all the images of the instances of your image with the reference dataset. And we will see that how we can do that during the answer with a very simple way using a virtual image providing an FS server. You have there some example of the different interfaces that are available according to the virtual images you are running. There are some based on command line. There are some based on portal, like the AirSat portal or the Galaxy portal. Also the Air Studio portal, providing you with a web interface. And there are other tools like Petty Checker or like a tool for genomic population ecology that are running through a remote desktop using KDE or GNOME remotely on the virtual machine. To manage your virtual machine, your storage, you go to the dashboard where you have the list of your running virtual machines. Also, you have the quotas you are allowed to use. And right from the beginning of the IFB cloud, you see on this graph the number of variants that are running at the same time on the ISV core cloud. And you can see that now we are around 120 virtual machines running at the same times on the ISV cloud. And especially you can see some peak there. They are most of the time during some trainings that we are running periodically. Now some example of virtual images. One of the first we developed is the biocompute node. This is a very simple image, providing only the command line interface, but providing with common tools like BLAST, FASTA, ClusterW, GoTile, WR, MEM, etc. And as a user, you can launch one machine, one instance with this image to do your analysis, but you can also launch several of them and turn them in a virtual cluster. We are providing you with some scripts to set up automatically the cluster. The cluster is also sharing a file system, and you have different batch scheduler like some Grid Engine or Torquay PPS. Another example of images available on the ISV cloud is the one providing you with the R statistical computing environment. So you can use R with the command line. You can also use R with the RStudio web interface, like we saw in previous presentation. And you have also access to the Shiny web framework that lets you develop your own portal for using the R modules through the Shiny interface, and then you have the different modules for analyzing your data or displaying them through a web portal. And one example of images being developed by external people from the ISV hub, ISV core, is this one, because it was developed and it's now maintained by Stéphane Delmotte from the ISV Pravi, located in Lyon. Another example of images are, of course, the Galaxy portals. We have different images of Galaxy providing different flavors of analysis. For example, we have a Galaxy image for modelization of data, the model one. We have one for RADSEC analysis. We have other Galaxy flavor portals. And each user can launch his own Galaxy portal to do his analysis with the predefined tools. But as this virtual machine is a personal user, the user can also be administrator of this virtual machine, and then install the tools, other tools from the toolshed, the main toolshed, or for example the ISV toolshed, and it is as easy as installing a tool with Galaxy. So sometimes it could be easy, and sometimes it could be difficult if the wrappers are not good. But that's not that's usual way of installing Galaxy. An important point is also that you can set up your own Galaxy portal for a training, for example, and it's quite easy to do that if you know how to install tool in Galaxy, of course. Another example of images is the IGV. So IGV is a genomic browser, and the platform IB Nigal and Marilor did some developments to provide IGV with some multi-genomics view, where you can have different genotypes displayed in different windows, and you can browse these different genotypes on the same instance of IGV. So this IGV image provides the user with a remote virtual desktop. So on your own virtual machine, you can run IGV close to the data and with some resources that can be 20 cores or 200 gigabytes of RAM, very close to the data. So that's better maybe than getting the data on your laptop and running IGV on your laptop. But we have also other appliances like the ELIXIR portal, like Petit Checker, or like Hadoop that are available in the IFB marketplace. These virtual machines are ready for science, but also for training. So we are doing different training. Some are devoted to learning the cloud. These one are training about how to learn the cloud. So they were done since 2 years and in different locations in Ivy Core or in Gen West, or there was a scientific school. But you see that the participants are many at each training session, because most of the time we have more than 20 participants and sometimes 50. Since the beginning of this year, we are running several courses about how to use the ISV cloud. So the first one is EV1. It's about ISV cloud basics. The description is in French yet. But what is important is that we have already 2 sessions of that in February and in April. We are running such basic introduction to the ISV cloud every 2 months. And the participants are beginners on the cloud, but users of bioinformatics services. And during the hands-on, we'll do a part of this introduction to ISV cloud. The second level of our courses are EV2, ISV Cloud Advanced, where you need to have already followed the previous level, or you need to have some previous experience with cloud or with the command line. And the goals are to be able to deploy complex application or with several tools or with several components, like an FS server, like a web portal, like a database management system, and so on. And we did already 1 session in May, and we plan to have such EV2 session every 3 months. And the third level is for developers, where you need, of course, to have followed the 2 previous ones, and also to know the Linux operating system. And the goal is to learn how to integrate your tools, or a pipeline, or in different interfaces, like, of course, the command line, but also in the web portal or in a remote desktop. We are running such a course every 6 months, and we already did a first session of EB3 in March, and we are planning a second one in July. In March, this session was done for the French genomic infrastructure, the developers of this infrastructure, and French genomic is the genomics infrastructure in France. All these descriptions are in French yet, but we are planning to translate them in English to be available also in the ELIXIR context. You can find them on the IFB portal with the next session. We are also providing master courses with the Cloud IFB. You have there the different courses, university courses that have been run on the IFB Cloud. They are provided to master in first year or second year, and they are from 10 to 38 students participating to these courses. These courses can have run for 1 or a week or several months. And these courses was requiring different tools and interface. For example, this one used the standard biocompute node and Galaxy infrastructure image we are providing, but other one, like the one about AirSat, was done with the specifically developed AirSat image. Also, this one was run with the Jupyter Notebook, especially put in a virtual machine for that master course. So all these are, you have there the list of teachers, and what we are providing as IV to these teachers is the way of setting up their own virtual machines if the available ones are not enough for their courses. But also we are providing them with support, and if the time is enough, also to follow the courses of how to develop your own virtual machine. That was for the 2 previous years, and yet there are already 3 new courses that are planned for until the end of year. So as a conclusion, we have a pilot infrastructure running since 2 years in 2 IB's data centers. We have 2 other running in collaboration with academia centers. Yet we have 36 bioinformatics appliances already available for different life science domains. And we have still several new images in progress. Right now, we have a little bit more than 350 users. And since 2 years on the IB Course Cloud, there have been more than 9,500 VM created. We are providing support for the training. We are doing some training about how to use the cloud. There have been already 8 cloud sessions, but we're also providing support to scientific training for 4 of them, and to master courses for 5 of them. That represent 130 students that have been using the IB cloud for their courses. 3 are already planned for until the end of this year. And in general, the IB infrastructure is available to the members of IB and the French life science community. They can be academic or commercial. Of course, there are some special condition, terms and conditions for commercial use. They are also open to partners of academic, industry, infrastructure, and projects, like the national one, Biodata Cloud, Profi, MetaboHub, France Genomic. They can access to the cloud. We are also opening our resources to our partners in the context of the European project, like ELIXIR-FR, Cyclone, and J-Engage. And it can include, of course, trainers and trainees, because regarding this workshop, one question was about how the trainers can use the IB cloud. That's completely possible. You have to contact us, and we will explain you the different conditions. Most will be that these trainings need to be run in the context of ELIXIR-FR. You need to provide us with a list of the participants in order to create the accounts, the temporary accounts for the tutorial, like the one you get for the answered session after that. And also, we need to discuss the visibility of the course and the resources, because if you are requesting to run your course, your training on 1,000 course, of course, yet it's not possible. And another important point is that when the teachers have developed their own virtual machine for their courses or for their trainings, the virtual machine stay available for the students, of course, but also for the other users of the IAV cloud. And it's also important to let us know if there are some public site, public pages describing the tutorial, in order that we can advertise all the cloud users of IAV of the availability of such a tutorial for a specific domain like RNA-seq or proteomics or so on. So don't hesitate to contact us, Victoria or me, for that. better is Victoria, because she's dealing with that part in ISV. Me, I'm only on the back-end part. Prospects are about extending the national cloud site. As you saw, we are planning to have a first extension before the end of this year. We also are planning to help regional centers to deploy a cloud. And we set up a task force about that with several voluntary platforms. And then with these new clouds and the existing one to federate the national and the regional clouds. We are also, of course, planning to expand the catalog of bioinformatics cloud services with new VM or container images. We will try to make this resource access simple with the European Federation of Identity, or the French at the first step, maybe, and with multi-cloud deployment tools. Right now, as you can see, the VMs are personal and cannot be shared between the different users. We are working on trying to provide a collaborative working space to solve this issue for some application. And also what we are doing is to set up a continuous integration environment based on Puppet, based on also on Foreman, connected to the Docker Hub, connected to the OpenStack infrastructure, in order to be able, from GitLab or GitHub, to be able to automatically build the images of containers or of virtual machine, and automatically put them in the marketplace for validation. So, to finish this introductive part, I would like to thank, of course, all the members of ISV Core, and also the members of the working group ISV Grisby, dealing with this part of infrastructure in ISV, but also all the appliance developers. They are not all there, but this is a good panel. Also, Idris, which is hosting us, and the different funding agency for the financial support they are providing to us during these years. Thank you for your attention, and if you have some questions.